some algorithm can calculate the universe partition, which you can give to a statistical physicist to unravel the secrets of our universe somehow. I'm not that deep into physics, but here are my 2 cents. So we would like to choose A such that this algorithm is optimized. When I say optimization, you think of a function which you take the derivative of and you set to 0 to find the extremas. So that's good. You already have a function. Everything's looking promising. Then you're like, okay, this is a function of n. I'll take the derivative with respect to n and then set it to be equal to 0 and then see which choice works for A. But then, but then you won't really get anywhere, because what are we trying to optimize? That is the parameter or the hyperparameter. I mean, as per the equation, the original equation. And we're not looking to optimize precision. This doesn't actually make sense to say optimizing precision. And even for the context of our problem, if you want to optimize A, you differentiate with respect to A. If you want to optimize with respect to n, sure, then you can take the derivative with respect to n, and then you set it to be equal to 0, and then you do your casual procedures. So in this case, we look at the derivative of t with respect to a. Now you get the derivative of a squared over 2 with respect to a. So this will give you 2a divided by 2. So it's just a. And then you take away what? Well, you want to take the derivative of this expression, but notice that this is a multiplication, so I can just write a here, and then let me continue to write all of this in red. And if I still need to differentiate this with respect to a, then okay, this is a, and this is a constant with respect to a. So this is not a constant in general, but if you compare this to our parameter a, it is fixed with respect to it. And so if this is true, then we can just treat this thing as if it's not there, as if it's just a constant, and then the derivative of a is 1. So we don't need to write anything. And now your problem is actually much simpler, because if you let the derivative you just found equal to 0, you get immediately that a will be equal to e to the n sine of 2n divided by cosine of 2n plus 1. Okay, I can write the e to the n as a simplification here. Perhaps this could be simplified. By this I mean the expression on the right. And this is true. So this is one of the formulas. A cosine of 2n plus 1, or 2 theta plus 1, is equal to twice of cosine of n, well, cosine squared of n. So if you have a cosine and you square it and you double it, it's the same thing as taking cosine of double the angle and you add 1 to it. It's a trigonometric identity. sure. But then what? Then there is one remark, because it's not just that. If you have this, and on top you have sine of 2n, then there is also another trigonometric identity, which I think this one is more notorious than the other one. So sine of 2 theta is 2 of sine theta cosine of theta. I think this is standard. I hope so. Well, if this is true, if you believe me for this, then you would cancel the 2's out, and you would cancel the cosine with the power, and then you would get that A is equal to e to the n times sine of 2n by cosine of 2n, which is just e to the n times the tangent of 2n. So this exercise is not at all tedious. You just need to know which derivative you want to take, which variable you want to optimize. And if you're able to identify this variable correctly, then you should be quite successful, and not just in this problem, but in all other problems, and hopefully in all endeavors of life.